The width of a rectangle is 2x plus 3, and the length is x plus 7. What is the area of the rectangle? So let's answer that question first. How do I find the area? Length times width, right? Multiply. How do I multiply? What would I do? The box method, yeah. Or you can use FOIL, whichever one you prefer. Who likes the FOIL better? You like the FOIL better, really?
I find it like at first I'm like, okay, wait.
Okay, well, you do the FOIL. I'm gonna do the box. So 2x plus 3. 2x plus 3 and x plus 7. Can you see it now? H, Y, V, I, X. What, babe? There's some to show there. So 2x times x will give you what? 2x squared. 3 times x, 3x. 7 times 2x, 14x. 7 times 3, 21. So from here, I'm going to combine like terms. So that'll give me 2x squared. 14x and 3x will give you 17x. And then plus 21. So here's the area of the rectangle. And for the sake of time, let's not worry about the perimeter, okay? But if I was doing perimeter, I would add all the sides together, right? So that's just combining like terms. So that should be pretty simple for us. Okay, so go ahead and write that in and submit that.
Miss, how do you put the exponent on phone?
Just do like just write it as 2x and then that little caret top and then 2. That's what it'll look like.
All right, thank you.
You're welcome, babe. Yes.
So with the FOIL, are you going to get the same like answer?
Yes, you should get the same answer. So let me see the FOIL method. So the first term, so 2x times x is 2x squared. The outer terms, 2x times 7 is 14x. The inner terms, 3 times x is 3x. And then the last terms, oops, not last. 3 times 7 would be 21. So yeah, you should get the same exact answer. All right, we ready?
Hey,
take a breath.
Miss, I accidentally wrote 10 on the end of mine.
What, babe?
I accidentally wrote 10.
It's okay. I know you meant 21. Definitely. All right. Take a breath. We're about to go in. All right. So exponent rules. So there's 5 of them that we're learning. 5 exponent rules. Okay. So 5 rules. Okay. This is the first rule. Product of powers. Is this on your formula chart? No. No. Yes, it is. I don't know. I gotta look. No, it is on your formula chart. But anyways, right now. Product of powers. Okay. Product of powers. That's the first rule. This rule states when you multiply 2 expressions with the same bases, you add their exponents. And I'll explain what that means, but let's write the definition. When you multiply 2 expressions with the same bases, you add their exponents. What up, Gareth? Hurry up. When you multiply 2 expressions with the same bases, you add their exponents. So let's say I'm going to use these for an example. A to the power of m. This A is called a base. The m represents the exponent. So the number or the letter or the variable that you're applying the exponent to is called your base. what is being raised to is called the exponent. So there's things that have to, conditions that have to be met. They have to have the same base. So if they have the same base and you're multiplying them, you add their exponent. You add their exponent. So let's say I had x to the power of 4 times x to the power of 3. Are those the same bases? Yes. So what do I do with their exponents? Add them. So that's x to the power of 4 plus 3, which is x to the power of 7. And yes, Leo, I'm going to start off easy, and it is going to get harder as we go, though. Okay, what if I had x to the power of 4 times y to the power of 3? Are those the same bases? No. So can I add their exponents? No. So it would just be x4, y3. Questions? All right, let's look at another example. So x to the power of 4 times x to the power of 7. Because they're the same bases, you add their exponents, so that'll be x to the power of 11. All right, so let's see if you understand. Okay, so I have 2x squared times x squared plus y. What would I do with this 2x squared? Distribute. Say it with confidence. Distribute. So when I distribute this, 2x squared times x squared, are those the same bases? Yes. So what am I going to do with their exponent? Add them. So what would that become? Yeah, so 2x to the power of 4. But when I multiply it with the y, are those the same bases? No. So you're just going to put them together. So 2x squared times y. Does that make sense? Okay. And I honestly would have as many examples as you can write down on paper, because I told you it's going to get like 1,000 times harder in a minute. Maybe 1,000 is a little big of a number. Maybe 10 times harder in a minute. Okay, 1 down, 4 to go. Okay. Rodolfo, Justin, you good?
Yeah, miss, I'm straight.
All right. All right. Next rule is quotient of powers. Quotient of powers. This says when dividing two expressions with the same basis, you subtract their exponents. When dividing two expressions with the same basis, you subtract their exponents. When dividing two expressions with the same basis, you subtract their exponents. Okay? So if I had x to the power of 4 over x to the power of 2, what should I get? X to the power of 2, right? Because 4 minus 2 is 2. So that would be x to the power of 2, or x squared. If I had a to the power of 3, b to the power of 5, over a to the power of 7. So, okay, good. But this is what I want y'all to think about. How many of y'all automatically in your head were like, we'll do 7 minus 3 because 7's bigger, right? So it's always the top, what's on top in the numerator, minus what's on bottom. So it would be 3 minus 7, which would give you negative 4. So it'd be a to the power of negative 4 and b to the power of 5. Okay, so it's always what's on top minus what's on bottom. And again, I would probably make sure you write down this next example so you have something to look at in your notes. So here, z to the power of 7 over z to the power of 3. Subtract their exponents, which will give me z to the power of 4. Okay, here's one. What if I had x to the power of 7 over x? Subtract by what? Perfect, awesome. So you don't see x is to the power of 1, but x is to the power of 1. You're not going to see that 1 there, though. So it would be x to the power of 6. And this is how you can think of it. If I had x to the power of 7, that's 7 x's multiplied together. 1, 2, 3, 4, 5, 6, 7. Over 1x. Well, one of them is going to cancel out on top and bottom, leaving you with 6 x's on top. So that's why it's x to the power of 6. Does that make sense? What I just did? No? So let's say I had a to the power of 3 over a. Well, that's 3 a's multiplied together on top. So a times a over 1a on bottom. Well, if one's on top and bottom, I can cancel at least one of them out on top and bottom. So that will leave me with 2 a's on top. That's why it's a squared. Okay. So see if you can figure it out. Y'all so quiet. I'm thinking y'all understand. Y'all got to ask questions. You don't know? Talk amongst yourselves. Figure it out together. Anyone want to try to explain out loud what they think? Robert! All right.
So you just subtract the top of this one.
Okay, so tell me.
Oh, a minus 3 is 5.
So I'll give you k to the power of 5. Okay.
5 minus 7 is negative 2.
Awesome. So that'll give you j to the power of negative 2.
X minus x is
Perfect. Yes. Good. Thank you. Whoop, whoop. Go, Robert. So yes. So let's see how we do. Oops. Huh? Girl, answer. This is the way I know if you understand. This is the only way. Where did my thingy go? I want to clear this.
Isn't it?
I don't see the word. What happened? Oh my gosh, what is wrong with me? Literally. Okay. I'm okay, guys. I'm okay. All right. 2 down. 3 more to go. Remember, there's 5 in total today. Power to a power. You're probably thinking, Miss Patterson, this really isn't difficult. LOL. It's when you start combining all the rules together into one problem. Don't worry, we'll get there.
No.
Power to a power. When raising an expression by a power, you multiply the exponent. Good question. When raising an expression by a power, you multiply the exponent.
We just like who thought,
Like,
you know,
what
hey,
workspace do you use this
let's
for? The dive teaching.
let's
The medical field.
that like will help us understand.
Think about like,
Absolutely nothing. Like, how does this apply to you? Remember last year you said that it's the math class, so then you can get to high school, and I get that, and that's very true. But like, how does this?
let me pause this before you. It says, when I raise something to a power, I multiply the exponent. So let's say I had x to the power 4, all raised to the power of 3. Because this is all being raised to the power of 3, I multiply their exponents, giving me x to the power of 12.
Oh, okay.
Okay, so 4 times 3 is 12. Again, I would have examples, and you're not going to remember it by just looking at definitions. And if you're the person who's just taking screenshots and blah, 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 you need to have examples. Trust me. Now, here's a question. Let's say I had 3 x squared y 4 all to the power of 2. This one I definitely want you to write down. 3 times x squared times y to the power of 4 all raised to the power of 2. So how many of you, looking at this right now, are thinking, oh, first let's just do 3 times 2, and then 2 times 2, then 4 times 2. That's what you're thinking. But is 3 an exponent? No, it's a base. So this is, well, 3 is in the parentheses, so this squared is messing with the 3, but what is it doing to it?
Making it 9.
By 3, actually.
It's multiplying by itself. It is 3 squared. So if let's say I broke this down. This is 3 being squared. This is x squared being squared. And this is y to the power of 4 also being squared. So everything in here is being squared. 3 is not being multiplied to 2. 3 is being squared. So 3 squared is 9. X to the power 2 to the power 2. X4. And y to the power 4 to the power 2? Y8. Okay, pause. I need you to get this because I'm telling you, it's just going to get gradually harder. If you didn't understand, say something now.
I see why I understand it, but I
Okay, so everything in the parentheses here is being raised to the power of 2. Right?
So as soon as that 2 is there, everything's getting okay.
Yes. The issue is what people want to do is they're like, well, the rule is multiply the exponents. So people are like, oh, okay, 3 times 2 is 6, so this should be 6. But that's not an exponent. 3 is not an exponent. 3 is a base. So 3 is being raised to the power of 2 as well. So that is 3 squared, not 3 times 2. Or you can think of it this, 3 is to the power of 1. So when I multiply their exponents, that is 3 squared. X is squared, being raised to the power of 2. So I multiply the exponents, giving me x4. Y is to the power of 4, being raised to the power of 2. Multiply their exponents, giving me y to the power of 8.
Oh, I thought like 3x squared was the whole thing.
So yeah, think of it as like all separate bases kind of thing. Yes. Thank you for asking. Okay. It's okay, guys. I think y'all stress yourselves out. Like, it's okay. It's okay. Okay, so this is just another example, much easier. W to the power of 5 to the power of 4. I multiply their exponents, give me w to the power of 20. Okay.
Go back to the other. Wait, let me erase it.
I can undo it.
Okay.
Okay, the big thing here is make sure you have all the rules written down so you can refer back to them when we combine everything together.
How many rules is there?
There's 5. Okay, 3 down, 2 to go. Well, now we're on the 4th one. Well, actually, we got to do this one first. So let's see if we understand. G to the power 4, B to the power 3, all raised to the power 2. Mm.
Oh no.
Don't you?
Actually, I thought it was gonna be hard because you make it seem so hard. Like I was like, oh, she's gonna do a lot of work.
Everyone didn't answer. Don't be waiting. Let's go. Now make me undo the name so I can be looking here and call you out. I'm not gonna expose this lone person though, so I'm not gonna do that. Okay, somebody explain.
You just oh sorry.
Jada, go ahead.
Okay, so you multiply the 2 by D4. Wait, D. Yeah. And then D8 and then wait, no. Yeah, that's right. Okay.
Time's up.
And then D, I mean, D to the 3rd power, right? And you multiply that by 2. And you get Z to the 6th power.
Thank you, Jada. Beautiful. Okay, now the reason whoever got C, I don't know who it is. You put a plus sign here. Okay, you don't see a plus sign in here. They're multiplied together, so you keep them multiplied together. Okay, it's a simple mistake. At least you got the right exponents, right? But they don't just insert a plus sign. Okay, there was no plus sign in the beginning. Okay. All right. Oops. All right, we're on number 4. On number 4. The last one is the easiest one, okay? So that at least that'll give you some something to look forward to. All right, negative exponent. Okay, this one's a little bit more difficult to understand by reading. I'll have to just show you. So when an expression is raised to a negative exponent, you put the expression in the denominator and change the exponent to be a positive. So when an expression is raised to a negative exponent, you put the expression in the denominator and change the exponent to be a positive. Yes, it's the longest one. And I think it's the hardest to comprehend by definition, but it's not hard to do.
Did you make this up yourself?
Did I make this up myself? No. I just looked up everything on Google. You know. I mean, I've been using the same.
Smart teacher right there.
I've been using the same Nearpod for like 4 years. So.
She's resourceful.
Mm-hmm. What, Leo?
If you looked it up on Google, couldn't any other person like
Teacher, don't
I'm talking about the definitions. Like I looked up the definitions. Yeah, I could. But would you actually look it up?
Yeah, I can find either.
All right. So this says, so for example, let's say I had x to the power of -4. So blanket rule for the rest of today and tomorrow. If there's a negative exponent, yes. If there's a negative exponent, it is not all the way simplified. You should not have any negative exponents when simplifying expressions with exponents. If there's a negative, you have to continue to simplify. It is not simplified until all exponents are positive. Okay, so to make this positive, I would end up putting this in the denominator. So x to the power -4 will actually go in the denominator, but it will turn into a positive exponent in the denominator. Okay, and this is blank, so what I put is a 1 at the top.
Oh,
Is that all there is to it?
that's smart.
Yes, the issue is like, not the issue, but the more complication comes when you add other stuff to it. Okay, so x to the power -4 turns into 1 over x to the power of +4. Okay. Nah, we about to put in that work, girl. We about to put in that work. All right. Okay. Remember, positivity. We're almost done. I need you to stay positive. Okay. So let's say I had g to the power of 2. I'm gonna start combining some stuff. Okay. G to the power 2, y to the power of 7, all over g to the power of 5, and y to the power of 2. Okay. I'm combining two things now. No, you with me, babe? I'm combining two things now. I'm combining the division rule, and then you're going to end up using the negative exponent rule. So these are dividing. So what does the rule say about their exponents? Subtract them. So g to the power 2 over g to the power 5 will turn into -3. So that's g to the power -3. Y to the power 7 over y to the power 2. Y to the power 5. Is that all the way simplified? No, because there's a negative exponent. So where will g to the power -3 go? The denominator. But y to the power 5 stays on top because that's a positive exponent. It's going to stay on top. So this will end up being y to the power 5 over g to the power of 3.
Question.
Yes.
What if you say you had a problem, would it specifically say whether you were doing the division of the quotient part or the negative part? Or
It will not physically tell you, but you have to understand if there's like a line here, that means division.
right. No,
Yeah.
I'm saying like obviously it's division, but in like the test, would you have to do this part
Yes.
no matter what it is?
Like, what do you mean?
Okay. I don't know how to explain it. So obviously like we did the division once, right?
Yes.
So in a test and there was like a division question, would we have to do the negative part if we got a negative?
Yes. So yeah, an exponent is not all the way simplified unless there's all positive. So if you see a negative, then you have to keep simplifying. Okay. No, babe, what are you doing? Noah, what are you doing? Whatever you're on, stop. I need you to focus, please. You're not on anything? Okay, so here I have x to the power -3. That will turn into 1 over x to the power of 3. All right, let's see if we understand. So that says c to the power of 4, f to the power of -3, z to the power of 5. Simplify. That is not all the way simplified because there's a negative exponent.
Oh.
All right, it's looking good. So that f to the power -3 would just go on bottom, right? Awesome. Good job, guys. Excuse me, Jada? All right, last rule. This is the easiest one. Zero exponent. When raising an expression by zero, it equals 1. When raising an expression by zero, it equals 1. Anything raised to the power of 0 equals 1.
We could do a problem.
Except 0. Like, you can't do 0 to the power of 0. That is not anything. Try it on the calculator. So anything raised to the power of 0 is 1. Okay, so that's pretty straightforward. X to the power of 4, all raised to the power of 0, would be 1. X 3, Y 7, Z 1,000, all raised to the power of 0 is 1.
Oh, wait.
Not me saying 1.
Anything raised to the power of 0 is 1.
So it's all good.
So let's say I had Z to the power of 3, Y to the power of 4, all raised to the power of 0 over Z5, Y8. Here are Z's. A lot of you might first think, oh, let's do the division rule first. PEMDAS. I gotta do my exponent first. So this is raised to the power of 0. So this right here on top is just 1. So the answer would be 1 over Z5, Y8. Okay? So anything raised to the power of 0 equals 1. Okay. We've learned all 5. Are you ready to put this into practice? Yeah! Woohoo! Okay, so that's just another example. Okay. I want 100% on this one.
Oh.
So
I think why not? This is so. Imagine she gets
Also,
around.
like,
Imagine she gets around. And everyone thinks it's like-
Right? You're just looking at the screen.
The way you
No, it's not.
Sure.
Positive.
Everybody.
All right. Yes, the answer is 1. Okay. All right. Let's get a little bit more difficult.
Oh, it's gonna be. Oh, I kind of get it.
Okay. I don't want you to submit what you have. I want you to try to figure it out. I want you to talk amongst yourselves and really try to figure it out. And then I'm gonna give you about a minute, 30 seconds, see if you can what kind of brainstorming y'all can do. Say what? No, this is not combining all of them. This is 2 rules. If you want to just do it on your journal, you can.
Not yet. Is it like?
What, babe?
Is it subtracting?
It'll be the division rule. So yeah, you're gonna subtract the exponent, and then you're gonna do any negative thing, the negative thing as well.
Oh, yeah, that's not good. That's not good. Oh my gosh.
You are.
The first one was when you multiply. What do you do? You add. You add the exponents. I was thinking multiply. Multiply. It's just that there's no. Oh.
Oh, okay.
Yeah. Like 10 times 5 is
Oh,
20.
really?
No, it's not. No.
It makes sense. But I already know the answer.
Okay, what is it?
Mm-hmm.
The negative exponent rule.
Well, there's a significant difference.
No.
Like,
I know.
everything
But
is different.
I know.
All right.
Okay,
I don't know.
I don't expect you to have the answer, but I want us to talk about it. Okay?
I go with G.
Okay. Okay. Fine. I'll take opinions. What do you think?
I think
H.
H.
I hear G. I hear H.
I think H, but I got it wrong. Well,
Okay.
How about I choose G and H?
Okay. Let's see. Okay. 14. We're gonna when we do these, we need to go step by step, variable by variable. Okay. 14 over 8. How many of you thought to subtract that? Are those exponents? No. If this was a regular fraction, 14 over 8, would I subtract 14 over 8?
No.
No. You would what? Reduce it, right? What is 14 over 8 reduced?
8, 16. Wait, are you doing it in graph?
Sorry, let me change it.
So you mean like
What's wrong with
14 divided by 8?
Yeah, 14 divided by 8, right? That's what that symbol means. So what you would usually do is reduce a fraction. You don't subtract the two numbers. I reduce that. These are not exponents. So 14 over 8, they both are divisible by 2, so that'd be 7 over 4. Okay? So G is automatically out. Okay?
Yay.
Oh!
Right.
I had all the exponents.
Miss, I was in between G and H, right?
Okay.
It's okay. It's okay. Everybody does
I
it.
now I get it.
Okay. A to the power 4 over a to the negative 2. You need to use a calculator if you do not know how to subtract negatives. That's not being mean. That's you have a calculator, use your resources. 4 minus negative 2 is positive 6. So that would be on the numerator, a to the power 6. B to the power 6 over b to the power 3. 6 minus 3 is 3. So that will be on the numerator because that's a positive exponent. So b to the power 3. C to the power negative 10 over c to the power negative 5. Negative 10 minus negative 5 is negative 5.
What? Negative.
Literally
No,
six.
not minus.
Okay, so this is my suggestion. Just use a calculator. Okay, that's negative 5. So wait a minute. If that's c to the power negative 5, do I want a negative exponent? No, so where should this go? And the denominator, the bottom. So that'll be c to the power of 5 on the bottom. So yes,
You just subtract them?
yes, negative 10 minus negative 5. So good job for my people who said H. Good job.
Good
Because you had chose.
Wait.
That you
So it is H.
Yay.
Good job.
Okay, that I can
See,
see.
Miss, I actually did.
Good, I'm proud. Okay, it doesn't matter. Okay, this last one, let's call this the exit ticket. Let's see if you got it. Nah, we about to put in that work.
Holy balls.
But this is the word you
This is gonna be
Nah,
the same
this just a light work. What you mean?
Where'd you get that from?
this like like
We got 40 minutes left. This is light work. Nah, they ain't no chilling. Ain't no chilling. I am gonna probably reduce the assignment though.
Yay.
Hey, y'all. I say, y'all better be glad this is virtual because I don't be feeling like typing stuff. But last year, y'all, it was like 20, 30 questions on this stuff that we do afterwards. That would take like 2 days though.
Honestly.
Is this not the same one?
It's basically the same exact thing.
Okay.
So, how you want me to stop?
You think you got it?
Already?
Like I said, I think. And in this case, so far that hasn't been very good.
Oh,
that's it.
I'm thinking this was somewhere else.
I think I got this. I got it. Go ahead. Okay. No, see you.
Oh, fun.
My grandmother
fun.
was gonna come, but then she had a whole bunch of
They are equivalent to 3. I think I
12 over 3 is equivalent to 4.
yeah, I got it.
12 over 3 is equivalent to 4.
I'm just a person. I think I'm like really smart. Like I got it. I think I got it.
Okay.
It's like the same one.
Einstein. Like, could Einstein do this?
Okay.
No, wait.
Even if you're not done, I'm gonna call individuals, not to be mean, just to see.
That's the only part I have done.
Okay, don't worry, that's why we're gonna talk through it.
No, you're my diggity dog.
Leo, 12 over 3.
I'm gonna do it.
Just tell me what 12 over 3 is.
Oh, what I do is 1 over 1.
4 over 1, okay, so I'm gonna just put 4. I'll put over 1. I'll keep it. Let me go put it in white over here. Okay, and I'm gonna extend the line because I don't know what else is coming. Okay, Robert, x to the power 6 over x to the power 2. So that'll give you.
4.
Okay, and that'll be on top or bottom? Top, perfect. X to the power 4, because it's a positive exponent, so it'll stay on top. Okay, Jada? Y to the power negative 4 over y to the power negative 6.
Y to the power -10?
Yeah.
It's subtracting. Yeah.
You're subtracting the negative.
So negative 4 minus negative 6.
Hint, hint.
Huh?
Listen, it's a positive.
Yep.
So what is it?
It's a positive.
Positive 2. Positive 2, yes. Okay, I don't know if y'all remember back in 6th grade, but keep, change. So this would be like, this is basically negative 4 plus 6. So when you subtract by a negative, that's the same thing as adding, okay?
Say thank you.
Yeah, thank you, Miss Hurley. So that would be y to the power of 2. Okay, Alexa, z to the power of 2 over z to the power of 3. It'd be negative 1. So where will z end up? On the bottom. So it would look like this, except there would not be a 1 right here. So who got that?
Me.
Yay! Because remember, if it has a negative exponent, so this is z to the power negative 1. So if it was z to the power negative 1, you don't want a negative exponent, so you will put it at the bottom. So it'll be z to the power positive 1. You can also think of it as this. Let's say it has z to the power 2 over z to the power 3. That's 2 z's on top, 3 z's on bottom. Well, after canceling out, you'll have just 1 z on bottom. Okay, so that's why it goes on the bottom. All right.